Welcome back to the channel, where we break down the stories that are changing our world before you even blink. If you thought 2026 was just another year of incremental progress, think again. This is the moment science finally cracked the code on controlled nuclear fusion, unlocking a nearly limitless clean energy source right now in labs across China and South Korea. We will also dive into how AI scientists are leading drug discovery at breakneck speed, the race for human longevity through gene editing, and why we might soon be looking beyond Earth to explore our own moons. By the end of this video, you won't just understand what's happening. You'll see exactly how these breakthroughs are rewriting the rules of physics, biology, and space exploration. Let's dive into the future that is already here. We started with the most critical question of our time. How do we power humanity without destroying it? In 2026, the answer arrived in a flash of plasma. Researchers at China's experimental advanced superconducting tokamak, known as EAST, achieved something that had been theorized for decades but never seen in practice. They successfully created a density-free plasma operating regime, stable and sustained enough to prove the concept beyond doubt. This wasn't just a flicker. They achieved electron densities approximately 1.3 to 1.65 times the Greenwald limit, which is the theoretical maximum density where fusion can occur before the reactor itself blows up. Imagine that for a second. For centuries, we have been stuck between fossil fuels that poison our atmosphere and nuclear fission that risks meltdown. This breakthrough suggests we are finally ready to harness the power of the sun trapped in a magnetic bottle. It is not a distant dream anymore. The stability achieved by the EAST team means that fusion reactors can now be built, tested, and eventually commercialized with a confidence that was non-existent 5 years ago. Simultaneously, researchers at Korea Advanced Institute of Science and Technology are pushing the boundaries further, refining the control mechanisms to make these reactions more efficient and cost-effective. We are no longer talking about fusion as a sci-fi plot device. We are looking at it as the next major industrial revolution. This means cheaper electricity, zero carbon emissions from power generation, and a future where energy scarcity becomes a thing of the past. While we were solving the equation for clean energy, another giant was being rewritten in the digital realm. Enter the AI scientist. We are witnessing the dawn of an era where artificial intelligence is not just a tool for analysis, but a primary agent of discovery. The rise of these autonomous systems has identified 8 emerging trends that are poised to scale commercially by 2026. From drug development to renewable energy, smart agriculture, and beyond, AI is doing what it does best, processing data at speeds no human brain could match. Consider the pharmaceutical industry. Traditionally, bringing a new drug to market takes over a decade and billions of dollars. Now, with AI scientists simulating molecular interactions in real time, that timeline is collapsing. They are identifying viable compounds for Alzheimer's, cancer, and rare genetic disorders with a precision that minimizes trial and error. This isn't just about finding hits. It's about understanding complex biological pathways that have baffled doctors for generations. We are seeing massive ocean floor drills scheduled to begin operations this year, gathering data on deep-sea ecosystems that AI will immediately analyze to find new minerals or understand climate regulation in the abyssal zones. This shift is profound because it democratizes research. Smaller labs and startups can now leverage supercomputer power that was once reserved for national governments. The collaboration between human intuition and machine processing is creating a feedback loop where ideas evolve exponentially faster. We are moving from an era of slow, linear scientific progress to one of exponential acceleration, where the pace of innovation is limited only by our ability to interpret the results. If fusion changes how we power ourselves and AI scientists change how we discover cures, then human gene editing is changing what it means to be alive. The year 2026 marks a pivotal transition point in regenerative medicine. We are no longer just treating diseases. We are actively rewriting the blueprint of life to prevent them before they start. Techniques that were once confined to theoretical papers and controversial debates have moved into clinical reality, offering hope for conditions like cystic fibrosis, sickle cell anemia, and even age-related macular degeneration. The implications go far beyond curing specific ailments. We are talking about extending healthy lifespans. By targeting the mechanisms of cellular aging, scientists can slow down the degradation of tissues, potentially adding decades to a person's quality of life rather than just their quantity. This is not the fiction of immortality. It is the realistic goal of stopping the biological clock from ticking too fast. The technology allows us to repair damaged DNA and replace failing cells with precision that feels almost magical. However, this power comes with weight. As we gain the ability to edit our own genomes, ethical considerations become urgent. Who decides what traits should be preserved or enhanced? How do we ensure these technologies are accessible globally rather than becoming a luxury for the ultra-wealthy? These questions will dominate the discourse of 2026 and beyond. Yet the scientific community is moving forward with caution but determination, driven by the desire to alleviate suffering and extend the window of human potential. The frontier of biology has expanded from studying life to actively designing it. Finally, we must talk about where we are sending our gaze next. With energy secured and diseases being conquered on a molecular scale, humanity is finally ready to look outward with renewed vigor. The rise of missions to explore the moons of Earth and Mars is no longer just a plan for the future. It is an active reality set to shape research in 2026. We are moving from looking at space as a place of cold isolation to viewing it as our next frontier for resources, habitation, and survival. The exploration of Earth's own moons, particularly Phobos and Deimos, offers immediate opportunities for asteroid mining and testing small-scale habitats without the need for the immense infrastructure required for Mars colonization yet. But the true destination remains Mars. The timeline is shifting from decades away to a window where human presence becomes a tangible possibility within our lifetime. These missions will not only seek new homes, but also teach us more about our own planet's climate and history than we ever could by staying here. The practical takeaway for all of us is that the barriers to entry are lowering. The technology developed for space exploration, advanced life support, radiation shielding, and sustainable energy systems is directly applicable to Earth-based challenges like clean water filtration and urban planning. We are learning how to live in extreme environments, which translates back to improving our daily lives on home soil. This is the exciting part. We are not just leaving Earth, we are leaving it better than we found it. The future of science is about expansion, connection, and a deeper understanding of where we fit in the cosmos. So, from the fusion reactors humming in China to the AI architects designing new medicines, 2026 is proving that our best days are actually ahead of us. We are standing on the precipice of an era defined by energy abundance, biological mastery, and cosmic exploration. The tools we have today will solve tomorrow's hardest problems before they even arise. If you enjoyed this deep dive into what's shaping our future, make sure to hit that subscribe button and ring the bell so you never miss another episode where we decode the science behind the headlines. Drop a comment below telling me which of these breakthroughs excites you the most. Fusion power, AI doctors, or space colonization? Let's keep the conversation going in the comments. Thanks for watching, and I'll see you in the next video.